Welcome to myprojectbazaar.com.
Our product title is low power clock distribution using a current pulse clocked flip. Let us see about the abstract of our product. In this proposed system is based on communication process. This design mainly consists three units such as a transmitter unit, interconnected network and receiver unit. Those three units having clock gating, flip-flop and passive elements. Here using mux based clock gating due to the processing time will be reduced. The process of low power EPDCO, that means explicit pulse data close to output. Flip-flop solves the long discharging path problem, thus achieves better speed and power performance. The synchronous design operates at highest frequency that derives a large load because it has reached many sequential elements throughout the chip. The synchronous design operates at higher frequency that derives a large load because it has reached many sequential elements throughout the chip. Thus, clock signal have been a great source of power dissipations because of high frequency and load. Clock signals do not perform any computation and mainly used for synchronization. Hence, these signals are not carrying any information. So, by using clock gating, one can save power by reducing unnecessary clock activities inside the gated module. The amount of power dissipation by any clock distribution system on sequential circuit in any chip is about of 30% to 60% of the total chip power dissipation by the circuit. Clock is the most important signal present in the chip. In this proposed implementation design is focused on the above mentioned drawback. So overcome that in this design, and this is done in Tanner EDA tool using of CMOS technology, and the NM is a 45 nm technology. Next we see about the flow diagram of our process. The main flow diagram is the mux based clock gating. So initially the clock is given using a mux based clock gating. After that connected to the transmitter side using of interconnected network. In the transmitter side we using proposed EPDCO type flip-flops. So general we using D type flip-flops. So using of EPDCO, the power consumption and also the time delay will be reduced. And next one, the output of the transmitter is fed into the receiver. In this base paper that only did in about to transmitter wise. After that we enhanced using the receiver side also. And also in this process we using two kind of enhancement. One is the mux based clock gating and another one is the transmitter side. In this proposed implementation is design of low power EPDCO and data close to output flip-flop using mux based clock gating. To overcome the time delay has better speed performance, a powerful pull down circuitry is needed. Such kind of problems we can drawback using of this kind of the implementation. The overall area and power consumption will be reduced. In this circuit contains total transmitter and receiver circuit, and all transmitter circuit is checked by using of the mux based clock gating technique. In the transmitter block having D flip flop have using of EPDCO type of flip flop. The main advantages of the this kind of flip flop is reliability is high and the output efficiency is also. Next we see about the running process of our product. In this proposed implementation is done in CMOS technology using of Tanner EDA tool and also using some nanometer technology. Using of 20 nm and 45 nm nanotechnology we use it for this process, and the CMOS technology is used the only PMOS and NMOS transistor. Then arrange the corresponding diagram as per the given circuit diagram. Then open the new file and then create a cells. So in these cells we set the setup library files, which location you saved the library file, and also we set the transient analysis timing, and then we add the library for using your library files. After that we arranging the elements and transistor circuits using the given base paper and flow diagram. Then we click the run icon, the output will be open. First of all the T-Space window will open. In the T-Space window the main process is the corresponding CPU times how much time taken to get the output. And also in this overall process, first of all the counter, new transmitter and receiver, and proposed CMTX and SISO, that is using of EPTCO flip-flop, the application's counter and SISO is derived, and this is the corresponding T-spice output, and the delay time is calculated using 9.6747 e power minus 9. And next one is the WEdit. In the WEdit window, the output will be open. So this is the power output. The power is the 270 microwatts for our transmitting and receiving purpose. And next one is the uh, below scope is the input and output waveforms for corresponding. And next one is the corresponding input and output waveforms. So this is the counter output waveform. So if you want to calculate the FFT for using this corresponding process, click that, the corresponding frequency value will be shown. The frequency value is 500 megahertz. So using of this kind of CMOS technology, the overall power consumption will be reduced for the overall process. If you take the screenshot, click the screenshot icon, then the scope will be displayed. The overall process will be increases the efficiency due to the reduction of power consumption and time delay. Thank you for watching this video.